Good morning friends, welcome back to Relief Tutorials. In the previous lecture we have discussed about some numericals from exercise regarding distance, displacements, average speed, average velocity. Also we have discussed one important topic in the last lecture, that if the particle is not moving with the constant velocity, if the particle is not moving with the constant velocity, that is called as non-constant velocity. We know that velocity is a vector quantity, so it has two characteristics, magnitude as well as direction. If magnitude and direction both remains constant, then only the particle traveling with the constant velocity. Out of these two, if one of them is not constant, in this example magnitude is not constant, in this example direction of the motion is not constant, you can see, and here both are not constant. So all these three are non-constant velocity and it is called as accelerated motion. So the motion in which the particle is not moving with the constant velocity is called as accelerated motion. Now accelerated motion can be because of changing direction or because of changing magnitude or both. We have discussed that in our syllabus in 9th standard we are having only such type of examples of accelerated motion in which the magnitude is not constant. The path will be straight, means the direction will remain constant but the magnitude will be changed. Let us take some examples to understand the concept very well. Consider, here is the straight path. Here the velocity of one of the particle is 5 meter per second at this point, and at this point the velocity is 10 meter per second. Okay. Another example. Here the velocity of a particle at this point is 5 meter per second, and at this point the particle's velocity is 15 meter per second. So in both the case, if you see the magnitude of velocity changes, here the magnitude of velocity changes, here also the magnitude of velocity changes, so both are accelerated motion, correct? Okay. Now the thing is, if I ask you in which, see the velocity changes, we understand that here was the velocity 5 meter per second, here is the velocity 10 meter per second, here in these examples also. Now example A and example B. In example A, the first velocity, this is called as initial velocity. The first observation is called as initial observation, means initial velocity. Initial velocity is symbolized as u. Initial velocity is symbolically represented as u, and this is the final observation, means final velocity, symbolized by v. Here initial velocity is 5, final velocity is 10. So can you tell me what is the change in velocity? What was the velocity 5? What is the velocity 10? So whenever you are going to find change, you have to subtract final observation minus initial observation. So what is the final velocity? 10. Initial velocity was 5. So the change in velocity is 5 meter per second. Already I have told you that change in terms of physics is symbolized by delta. So here change in velocity means delta v. Delta v means change in velocity. How you find delta v here? Whenever you are going to find change, that always means final velocity minus initial velocity. So delta v means v minus u. V, final velocity, and u means initial velocity. So delta V means final velocity minus initial velocity. Can you find delta V here in the second case? Delta V means change in velocity. Change in velocity means final velocity minus initial velocity. What is the final velocity? 15 meter per second minus initial was 5. So 15 minus 5 is 10 meter per second. See, try to use as much as symbolical language. That will be the great practice in the future. So try to understand the symbols. Okay. Now, what is the change in velocity here? 5 meter per second. What is the change in velocity here? 10 meter per second. So if I ask you that in which example, in which case the change is faster? Again, in which case? Say change here is 5 meter per second, change here is 10 meter per second. Okay, both particles starts with the same velocity. Okay, final velocity here was 10, here is 15. So in which case the change is faster? So to say or to understand that in which case the change is faster, we need to know that in what time this change is taken place. Yeah, one thing is sure that here the change is 5 and here the change is 15. That is true. But if I say this change is taken place in 2 seconds, and if I say this change is taken place in 10 seconds, so in the first case A, the change of, so in 2 seconds, the change is 5 meter per second. In 2 seconds, the change in velocity is 5 meter per second. And in the second case, in 10 seconds, the change is 10 meter per second. Now try to find out here in 2 seconds, just in 2 seconds, the change is 5 meter per second. And here the change is 10, but it takes 10 seconds too. So to find out in which case, the change is faster, we can find per second change. We can find what? Per second change in, okay, so per second change is required. Okay, so in the first case, in 2 seconds the change is 5 meter per second. So in 1 second the change would be how much? Let me write here. In 2 seconds the change in velocity delta V is 5 meter per second. So in 1 second the change would be how much? So 1 into 5 is 5 meter per second. Let me write the unit also upon 2 seconds. So 5 upon 2 will be 5 upon 2 is 2.5. 5 upon 2 means 2.5. 2.5 meter per second per second. In the very beginning of the chapter, I have told you that we cannot write the unit like this. Okay, in unit there should be always one numerator and one denominator. So let us write this second in the denominator. So what that will be? 2.5 meter per second square. So this is the per second change in velocity. What I am saying, it is what? Per second change in velocity we have found here. Look at here what we have found. Per second change in velocity in the language of physics, it is also called as change in velocity in unit time. This is also what we found here. It is also change in velocity in unit time. Okay, let us find the change in velocity, per second change in velocity in case B also. Total 10 seconds time, and in that what is the change in velocity? The change in velocity is 10 meter per second. So in 1 second it would be how much? So it is 1 into 10. that is 10 meter per second upon 10 seconds. So 10 cancel. So the change is 1 meter per second. So it is meter per second square like this. So here we can say that the change is faster in case number A. So this is what we have found in both these. This is the per second change in velocity. Per second change in velocity is called as acceleration. What is acceleration? It is nothing but the per second change in velocity. That is called as acceleration. Acceleration is symbolized by small a. What should be its definition? Per second change in velocity. But let me write in the proper way. Change of velocity in unit time. Change of velocity in 1 second means change of velocity in unit time is known as acceleration. Or another definition, rate of change of velocity is known as acceleration. So both the definitions are valid and both have the same meaning. Here the word rate is used in place of unit time. So both have the same meaning. This is the definition. Here we have found the x. So this is what? This change in velocity in unit time is called as acceleration. So these answers 2.5 meter per second square. What exactly we have found here? We have found the per second change in velocity. So what is our answer actually? Let me write the answer here. Carefully look at this. Answer was 2.5 meter per second per second. This was the original answer, but we cannot write the unit in this manner. So we have changed the unit as meter per second square. Look at here. Okay. But what do you mean by this actual answer? Listen to me. What do you mean by this? It means that 2.5 meter per second. 2.5 meter per second is the change in velocity per second. And what do you mean by this answer? 1 meter per second square. It means 1 meter per second is the change in velocity per second. Okay. So these are the answers of acceleration actually. So both the answers are of acceleration. Acceleration always represents. See, out of the definition, listen my words carefully now. Acceleration always represents that what is the change in velocity per second. Acceleration represents what? What is the change in velocity per second? How we found the answer here? What is the method? What we have done? See, 2 second total. What is the change? 5 meter per second. So in 1 second, it was how much? Simply cross multiplication method. This was our mathematical step. So what is this 5 meter per second? 5 meter per second is nothing but the delta V, means change in velocity. And upon 2 means what? It's the total time to require that change. So this way we can find the acceleration always. So what is there in the numerator? In the numerator we have change in velocity upon time. Here also, what is this 10 meter per second? The mathematical step. 10 meter per second is actually the change in velocity. Look at here. The change in velocity, and upon 10 second is actually the time. So we can find acceleration always by what? Change in velocity upon time. So we have a formula to find acceleration is formula acceleration is equals to change in velocity upon time. Symbolically, acceleration A is equals to change in velocity. Change in velocity means delta V, okay, upon t. Therefore, if you expand this delta V means change, and change means final velocity minus initial velocity. So we have A is equals to V minus U by T. So these both are same. This is the very important formula of the whole chapter. Many formulas we have already seen and many more we are going to see, but this is the very important formula of acceleration. A is equals to delta V by T, or also called as A is equals to V minus U by T. Okay. Now, what is the unit? Unit of acceleration. Unit can be derived from the formula also. Already we have seen unit of acceleration in this example as what? Meter per second square. Here also the same. So that is the unit. But if you forgot the unit, then you can derive it from the formula. See the formula, what is in the numerator? Delta V means change in velocity. Velocity is measured in terms of meter per second normally, and upon second. So meter per second in the numerator, upon second. So meter per second upon second will give you what? Meter per second square. So the unit of acceleration is meter per second square. It can be also represented as meter second raised to minus 2, and there must be some gap between this meter and second when you represent in this way. So meter per second square or meter per second raised to minus 2 this way. Remember, acceleration is always measured in these units only. Sometimes it is also measured in terms of centimeter per second, also represented as centimeter second raised to minus 2, but it is never represented, it is never measured in terms of kilometer per hour square. So remember, kilometer per hour square is not the valid unit for acceleration. So never use this type of units. If you have velocity given in terms of kilometer per hour, you have to first convert it into meter per second. Okay, then only you can go further. So unit of acceleration is meter per second square, like this only. Is that clear? Now further, let's take some examples. Consider this. Here the velocity of one of the particle is 2 meter per second, and here after some time the velocity becomes to 6 meter per second, and it takes 2 seconds to change that. Find A. If I ask you to find A, can you find acceleration here? A for acceleration? Yes. First of all, what is this 2 meter per second? 2 meter per second is initial velocity u. What is this 6 meter per second? That is final velocity. And what is this 2 second? It's a time. Okay, can we find A? Yes, we can find A. So A is equals to V minus U by T, the formula. Therefore, A is equals to, what is V? V is 6 meter per second minus U is 2 upon T is also 2. So 6 minus 2, 4. 4 by 2 is 2 meter per second square. Answer. But what I want to explain you is, okay, look at here. Can you find delta V here? Can you find delta V here? Delta V means change in velocity, and change in velocity is V minus U. Okay, so what is V? 6 and U is 2. 6 minus 2, 4 meter per second only, because it is not acceleration, it is just the change in velocity. So it is 4 meter per second. Okay, one thing. Another example. Initially, the particle moves with 10 meter per second velocity. After some time, its velocity becomes 2 meter per second. It takes 2 seconds to change this. So what is the initial velocity? Initial velocity U is what? 10. And what is final velocity? Final velocity is 2 meter per second. So now I am asking you to find delta V and A. Both things I am asking you, just like we have done in the previous case. Let us find delta V first of all. Delta V means change in velocity, and that is final velocity minus initial velocity. Therefore, delta V is equals to final velocity, V means 2, minus initial velocity is 10. So 2 minus 10, that is minus 8 meter per second. Here the change in velocity is negative, and I think you understood that why it is negative, because here can you see the velocity of the body decreases. Here the velocity of the body decreases, and here the velocity of the particle increases. So whenever the velocity of a particle increases, delta V is positive, and so the acceleration also positive. Now here you find A is equals to, can I write direct formula? A is equals to delta V by T. We had a formula like that also. So A is equals to delta V. Delta V means change in velocity, and change in velocity we found as minus 8 upon T is what? 2. So therefore A is equals to 2 4s are, so it's minus 4. So it is minus 4 meter per second square. So acceleration also negative. So what do you mean by the positive acceleration, and what do you mean by the negative acceleration? Positive acceleration means the speed or the velocity of the particle increases, and negative acceleration means velocity of the particle decreases. So now I think you strike one thing in your mind. You should strike that here acceleration is positive, here acceleration is negative. So I think acceleration should be the vector quantity. So it's very important thing to remember. A means acceleration is vector quantity. It can be positive, negative and 0. And look at this formula. A is equals to delta V by T. Here T means time, and time is scalar quantity. Time is scalar quantity, but velocity, change in velocity means velocity is a vector quantity. So for direction, see, therefore acceleration is also vector. Then what should be the direction of acceleration? So I think the direction of A will be totally same as what the direction of delta V, because A means acceleration. For direction depends on delta V. Direction of A depends on direction of delta V. Look at here. What is the direction of delta V here? Positive. So direction of A is also positive. Here direction of delta V is negative. Here direction of A is also negative. Let me remind you, for direction A means acceleration depends on delta V, not V. Not V, delta V. Change is important. So whatever the sign, whatever the direction you obtain for delta V, same direction, same sign you will obtain for A. So based on these, we have two types of accelerated motion, or two types of acceleration, 1 and 2. 1 is simply called as acceleration, and second is called as retardation or deceleration. Which motion is called as acceleration, or what is called as acceleration? In acceleration, velocity of a particle increases. And what in the retardation? Velocity of a particle decreases. Okay, so this motion in which the acceleration is positive, in which the velocity increases, this is called as accelerated motion, and this answer is acceleration. The type of motion is accelerated motion, and the answer is acceleration. Okay, and here the velocity decreases, so this type of motion is retarded motion, and the answer of acceleration is retardation. Okay, so here the velocity of a particle increases in acceleration, and in retardation the velocity of the particle decreases. Now one more thing, delta V is positive. In acceleration delta V is positive, and in retardation delta V is negative. Therefore acceleration is positive, and here acceleration is negative. Simple. Okay, so can I make a note here? Not here. Let me write the note here. Direction of acceleration is same as direction of change in velocity, not velocity, it's change in velocity. Means delta V, direction of A is same as that of direction of delta V. If delta V is positive, A is positive. If delta V is negative, A is negative. Here what? Here the velocity of the particle increases, so obviously V is bigger than U. And here the velocity decreases, so V is less than U. So whenever you find delta V, in acceleration that will be positive, and in retardation that will be negative. So that's all for today, or that's all for this lecture. Please make a notes of acceleration. Only we have seen the definition and the types of acceleration and the unit and the formula, nothing else. In the next session we will solve some numericals regarding that, and then we go further. Best of luck.